Good morning, everyone. Welcome to the 61st APAN IPv6 and 5G working group meeting. Thank you for joining us today. My name is HLAING from the Faculty of Computing and Informatics, Multimedia University, Malaysia, and I will be your MC for today's program. So without further delay, let us begin our program with the opening remarks by Dr. Muhammad Al-Nur Abdul Hafiz Fadul, co-chair of the IPv6 and 5G working group and associated professor at the University of Science and Technology, Malaysia. Doctor, over to you.
Thank you very much. Good morning, everyone. Distinguished speakers, respected colleagues, ladies and gentlemen. On behalf of the IPv6 and 5G working group, it is my great pleasure to welcome all of you in this session at the 61st APAN meeting, Dhaka. I'm honored to serve as a working group co-chair with my colleague, Dr. Navanisa from MMU. And it is truly encouraging to see such a strong participation from academia, industry, ISPs, network operators, and policymakers across the region, and also we have one participation from MENA region. APAN has always played a crucial role for fostering and supporting collaboration, innovation, and operational excellence in advanced networking. Today's program reflects that spirit very well. As we move deeper into the era of IPv6, 5G, and beyond 6G challenges we face, the challenges we are facing no longer just about address exhaustion like IPv6, but also about scalability, security, automation, and also future-ready network architecture. In this morning session, set a strong foundation with the keynote on IPv6 enhanced and net 5.5G, highlighting how IPv6 continue to evolve as a core enabler for next generation network. We then explored the importance of important operation and security perspective, including IPv6 neighbor discovery protection using P4 and SDN, software-defined network, as well as real-world challenges in securing IPv6 deployment. These topics are highly relevant as IPv6 adoption accelerates across critical infrastructure. After break, Dr. Nava will handle the sessions, and that's going to be including IPv6 only deployment rollout in other regions from India, Nepal, and MENA region, which is not APAN region. These experiences are extremely valuable as they move beyond theory and showcase practical lessons learned. Challenges encountered during this deployment and strategies that has been adopted that have worked on the ground. Such sharing is essential for broader community as many networks transition towards IPv6 only environment. With that, I would like to sincerely thank all our speakers for their valuable contribution and the APAN organizer for the continued support, and all participants for taking the time to join us today. Your engagement and discussion are what makes these sessions actually meaningful and impactful. With that, I would like to forward the productive and insightful sessions and encourage everyone to actively participate in the discussion. Thank you, and I wish you all successful sessions.
Thank you very much, Doctor, for your warm opening remarks. Now we are pleased to welcome our first speaker, Prof. Emeritus Sureswaran Ramadass, Chair of the APAC IPv6 Council, Vice Chair of the Network Innovation and Development Alliance NIDA, and Professor at RUMC. He will present on industry trend and insight and regional implementation of IPv6 Enhanced and Net 5.5G. Professor, you may begin your presentation.
Can you all see it now?
Yes, sir, we can see it.
If I go full screen, I think I won't be able to share it with you. Okay, so I'll talk about industry insights right now on the regional implementation of IPv6 Enhanced and Net 5.5G. At telco AI services globally, and it is at around 19 billion. But we estimate that by 2030, it's going to reach 112 billion. That's a 5 times growth over the next 5 years. So approximately 200% growth a year. At 2030, the total traffic is estimated at 101,875 EBs per month at 3.2 times 2025. So you have 18% what we consider at conventional traffic, 31% at AI enhanced traffic, and 100% is net new AI traffic. So this is the estimates right now that market studies have done. Survey on the network readiness in the AI era shows that if your existing IP transport network ready to cater to a sudden increase in AI workload demands, right? So you're going to see, these are the responses, by the way, by a survey that we did. And 26% say they are fully (53%), security challenges 49%, and lack closed loop automation at 40%. Which is net 5.5G. They start release process or start new technical reports and standards for net 2030 and IOA. So countries have already started working towards new methods, new technologies, new ways of interconnecting networks in the sense to overcome this potential we see that is going to become a challenge. Right? So one is the lack of bandwidth, the other is latency. Right? So moving on, we have another organization called WBBA. So WBBA has about 160 members worldwide, including 50 odd network operators. And they released Net 5.5G revision 2, introducing AI in all network domains. You can go to the WBBA website, you can download the documents regarding this. Right? So here they show you an evolution. And since the slides are a little bit small, so difficult to see, what we will do is we will share the slides after the presentation. Right? So if you look at it, there is a need for some things to change within networks. One of it, we on our side, in terms of IPv6, is the getting rid of nets. So we need end-to-end connectivity. Right? Nets will only slow down the network. Right? Translators will only slow down the network. So if I have end-to-end connectivity on IPv6, then my network speed, throughput, and latency, all three will increase. And we have seen that all three of these are areas that have been identified in the study that we have done with the ISPs, where they are concerned. So a focus on these areas will actually help. Now, we also have which will allow the setting up of an entire pathway, and it will dedicate bandwidth. So on demand, the NIDA industrial collaboration promoting next generation networks. So here we basically signed an MOU with ANA. So one of the issues we are facing is the ability to be able to bring this to industry. So the technology is there now, but we need to bring that technology to industry. Again, can you all see this? I'm not sure if I'm getting through or not.
Yeah, we can see.
Okay, that's good. Give me a minute. On my side also, the network has an issue. Yeah, it is. Okay. So we signed an agreement with NIDA, which sets standards for industry, and they're pushing new technologies and new industrial standards together with the APAC IPv6 Council for countries so that they can move faster to IPv6. And all of this is currently being done free. We don't charge anyone for this kind of help and this kind of work that we do. So the research areas of NIDA, the NIDA working groups include computing, intelligence, data connections, air-space connections, ultra broadband connections, IPv6 enhanced protocol extensions, new and new security mechanisms. These are the areas that we work on. Net 5.5G over more than 150 countries right now. 100, sorry. V6 is a key technology that we implement within this network. So we allow the creation and this creation of networks on demand. That means if I wanted a connection from here to Bangladesh right now to do this presentation, I will be able to create it. It'll automatically say, okay, what bandwidth do you want? And I would say maybe I need about 5 meg so that I can run my video conference properly. And that network will be created on demand. It'll ask you how long you want it, say for an hour, and that gets, it tries to make sure that it can create that network through the best path possible. There are pioneering practices that have been released both in KSA and in China. Shenzhen released the High-Speed Broadband Pioneering City Action Plan. This is within Shenzhen City. And they have, the city itself now runs a huge campus network, over 10 gig. So bandwidth is not such an issue anymore. And they are able to do things very fast, very quickly, especially in the AI era. In the Kingdom of Saudi Arabia, the gradual shifting from the 10G society to the regional AI hub has started. They have a Vision 2030, which is set to improve their digital infrastructure. And this move is already being implemented, well underway. And again, it's very similar to the Shenzhen city. It is to create a 10 gigabit campus network throughout society, throughout the basic infrastructure into the city itself. The proposed digitalization and intelligence anywhere and anytime. This is an interesting concept. It's a concept that is being looked at right now. And what we are saying is 400 to 800 gigabit. Okay, can be gigabit Ethernet IP transport networks with Wi-Fi 7 to enterprise and 400 to 800 gigabit data center networks. So you can, the proposal one is to upgrade IP transport networks, moving it up to 400/800 gigabit. The second one is to propose high quality enterprise campus networks based on Wi-Fi 7. And then finally, it is to upgrade data center networks towards 400. The effect for the release of that 5.5G. So we have the international global bodies on relationship to both IPv6 enhanced and net 5.5G. And we figured out that if you look at basically fundamentally how these two technologies work, Net 5.5G cannot be rolled out without IPv6. If you try to use IPv4 Net 5.5G, it cannot give you the performance and the requirements that you want. So you really have to use IPv6 for this. Again, here we are talking now back to SRv6. So what we have done under the APAC IPv6 Council as well is we've started looking at SRv6 as a standard-driven architecture. And the SRv6 standards are quite clear. You have an RFC 8402, RFC 8754, RFC 8986, and RFC 9352. All of them are different aspects of IPv6. In Malaysia, we have already deployed it under the MTSFB, Malaysian Technical Standards Forum Berhad, where MCMC MTSFB TC, or technical code G053:2025, has been already, has been standardized, and it's called Deployment Specifications for SRv6. Capacity building initiatives for NET 5.5G and SRv6. So we've done, APAC IPv6 Council has done quite a few workshops and presentations on basically 5G and SRv6. And upcoming is another workshop that will probably be conducted in Nepal in April during the April APAC IPv6 Council meeting. These are the efforts made by the APAC IPv6 Council for NET 5.5G and SRv6, different workshops. Okay. With that, I end my presentation. If you all need to contact me, you can contact me through the secretariat. Thank you.
Thank you very much, Professor. So our next speaker is Mr. Ram Krishna Pariya, Vice President of Technology at Suvisu Limited, Nepal. He will present on state of IPv6 in South Asia, region policy, infrastructure, and security. Mr. Ram, over to you. Yes.
Very good morning. Should I share my screen?
Yes.
Okay. Are you able to see my screen?
Yeah, we can see it.
Very good morning, everyone. Thank you very much for the IPv6 5G and IPv6 working group as well, right? This is Ramkrishna Pariyar from Nepal, as working as a vice president at Subisu CableNet. And apart from that, I'm also working with the different like local community and PNOG. I'm also the member of APAC IPv6 Council's members, right? And the so many other local community as well. Today I'm going to present state of IPv6 in South Asia, the bridging policy, infrastructures, and the security, right? If you can just see the IPv6 diamond, gold, and silver's country in like 2025 and 2026, we can see a lot of like good pictures represented from APAC as well, right? The diamonds, the global leaders who have adopted more than 60% IPv6, one of the leading countries from India, which is almost like a 79%. As per the data from APANIC, IPv6 lab, which reside in the diamonds. Likewise, in the Malaysia as well, so it's almost like a 71%. Saudi Arabia is almost 72%. Regarding the gold, it's like an advanced adapter for IPv6, who deploy IPv6 almost 40 to 60%, right? Nepal also near going to like cross 60%, is almost like 59.2%. Vietnam 61%. Sri Lanka also like a 55%. Silver that is like emerging adapter for IPv6. The host country, Bangladesh, is also part of Silvers, Pakistan, China, and the Australia. These are some like stacks from the global, which designs diamond, gold, and the silver country. If you can just see, especially in the South Asia for IPv6 landscape, we can see one of the top, India, because of the geo. Geo really helped to increase IPv6 in global stack and the APAC region as well, right? Pakistan's almost like 22.47%, Afghanistan 11.38%, India is leading, Sri Lanka 55 point something percent, Nepal 59.17%, and Bangladesh 17.79% is like a, as per the current statistics, right? And because of the geo, is really help to drive IPv6 in the APAC or its global stacks as well. We need to follow with the geo. We can learn so many things from the geo as well to deploy IPv6, especially for telcos prospect, right? And I think like uh, especially in the South Asian country, I think the awareness part is done. So many workshops from local NOG like BD NOG, NP NOG, BT NOG, SANOG, Apricot, and Epinic also did so many workshops in this region, right? And even though we can see like some of the country like Pakistan, Bangladesh also seems the percentage is less, right? We need to like more focus on the policy level as well, right? To drive IPv6. The security gap in dual stack network. As of now, most of the operators, ISP or telcos, they use a dual stack, IPv4 and the IPv6, both in the same device, right? There are some like security challenges the deploying in IPv6 and IPv4 in the same device as well, right? One of the like a part is uh, uh, most of the engineers, they block unnecessary things like they follow common best practices for incoming and outgoing traffic for IPv4, but they forgot to apply these things in IPv6 so that the door will be open. The bad guys can enter from that IPv6 as well. That means the invisible doors is there, right? Many ISP deploy dual stack but fail to replicate IPv4 access control list on the IPv6 side as well. We need to follow that rule as well, right? And another part is like a when we deploy IPv6 and not properly propagate those v6 in the global routing table as well, right? The latency is quite different than IPv4, right? The IPv4, the route is so much like predictive, and the latency also like a more predictive. And for V6, it seems like some lagging as well because of the we have not properly care to announce a V6 in the global routing table. That's why like the firewall policy will bypass from IPv6 so that the bad guys, the attacker can like enter your network through the IPv6 as well, right? That's why like we need to follow that security rules both to directions. The Nepal model for IP policy as an accelerators, right? If you can see from Nepal prospect, I think we have started IPv6 from 2007 or 8, right? And we did so many workshops, seminar from Nepal even during that time, we cannot increase IPv6 traffic and during that time as well, right? During that time, we just tested. We did a lot of workshops, seminars with the local operators, right? And after 2019, almost like a 2020, right? The IPv6 stacks, IPv6 traffic is like exponentially growth, right? You can see from the graph, iconic graph as well. As of now, it almost like the private operators, mostly they use IPv6 because it helps to save a lot of money from CGNAT, right? And the another thing is like IPv6 help network engineer life easy, right? That's why uh, in the context of Nepal, Nepal Telecommunication Authority, the regulatory body, also help to boost IPv6 in Nepal for all operators, right? Infrastructures engineerings beyond, like this is some example of the like IPv4 and IPv6, right? And uh, I already saying like most of the operators we use dual stack. That means use IPv4 and IPv6 on the same interface. There might be the chance of like almost 30 to 50%. That there might be the chance to be mistakes, or the resource will be overloaded. Right now, we need to move on native basics, right? Because like most of the like a CDN providers already have a basics. It's like a Akamai, Google, right? And the Cloudflare have a very good in IPv6 as well, right? Infrastructure engineering beyond route hygiene, we must enforce. Yeah, one of the major part for the like route hygiene is we need to apply RPKI, resource public infrastructures, sign your ROA, route origin authorizations, and I think especially for the APAC region, ROA seems better, right? But now we need to implement route origin validations. Validation is really required. Invalid route drops are critical for basic stability. CP management, yes, most of the like especially in the ISP networks, they fully implement the IPv6. Still, some of the device, the CP device, which does not support IPv6, right? We need to work on that, and we need to replace that device as well. DDoS mitigations is also like part, right? And policy and regulatory landscape, national broadband and digital strategy influence IPv6. Go ahead, accelerator, right? Regulatory mandate, accelerate adoptions, need for consistent regional policy alignment. Role of government and the regulator, mandating IPv6 readiness in public sectors network, including IPv6 in licensing and compliance frameworks. Nepal Telecommunication Authority recently work with the IPv6 bylaw as well, and they try to enforce all operators, private and the government operators as well, to mandatory for IPv6 deployment in their networks. Might be that policy levels help to adapt V6. And capacity building and awareness program, it's going, I think this is a very important for every country as well. The capacity building we did, but still it's lacking. I think we need to properly again conduct a workshop and seminar for capacity building as well. Infrastructure readiness, yes, core and access networks, IPv6 capability, customer premises equipment, CP compatibility. There might be some issue with some compatibility as well, right? And because the CP is already procured and already used in the network, right? And it is not easy to replace on a single day. So that gradually we need to work on to define fully compatible with basics. IX and data centers are key enabler for IPv6 readiness. I think most of the IX already in V6, both in the dual stacks, data centers also like a moving for IPv6, right? And most of the like a data center like AWS, Azure's, and Google's have the basics, P4 and B6 both. ISP and operators some challenges as well. Legacy IPv4 infrastructures, operations complexity of dual stacks networks, like almost like a 30 to 50% overhead tax is replicated, and the hardware's consume a lot of unnecessary resources for dual stack as well. That's why we need to go with the native IPv6. Skill gap in IPv6 planning and operations. Still, skill gap is seen, and we need to, especially for the enterprise networks. The way forward for South Asia, regional collaborations and knowledge sharing is required, both for the public-private partnerships is also required. Measurable IPv6 adoptions targeted. I think we need to define some date for native V6 as well for the every countries, right? Might be like 2030 or 2035, and based on that, like we need to work out with the data center, IX, operators, enterprise, and other applications part for the V6 enhancements. Okay. IPv6 is essential for South Asian digital futures. Balanced focus on policy, infrastructures, and the security. Now is the time to move from planning to executions. We did a lot of planning, but the planning without executions may not be fruitful, right? That's why we need to go in the actions for basics. Okay. And I think Dr. Suresh already mentions on that, like the next APAC Council meeting in Kathmandu, that will be, I think, April 9 and 10. I'll also like to request everyone to like join in this APAC Council in Kathmandu. Thank you very much.
Thank you very much, Mr. Ram. So up next, we have Prof. Dr. Supri, Dean of the Faculty of Computer Science, UPAN Veteran Jakarta, Indonesia. He will speak on latest issue and operational challenges in securing IPv6 networks. Professor, you may start your presentation.
Okay, good morning. Assalamualaikum warahmatullahi wabarakatuh. Can you hear me?
Yes.
Okay. Let me share my PPT. Can you see this PPT?
Yes, Prof.
Yes.
Okay. Assalamualaikum. Very good morning, everyone. Thank you for joining this APAN61 and give me chance to present the latest issues on IPv6 security. Okay, ladies and gentlemen, as we know, the internet technology has connected us from over the world. Me from Indonesia, UPN Veteran Jakarta, and you in Dhaka, in Nepal, also in Malaysia, we connected using the internet technology. Now, based on Water report on February 2025, almost 58%, 58% people connected to the internet. 70.5% connected using mobile devices. Okay. The hook use of internet make the IP addresses scarcity. So we need IPv6 that already introduced by ITF on 1995. Yeah, IPv6 has 340 undecillion addresses. So every millimeter square of Earth space can get more IPv6 address. Okay, then thank you for Mr. Sam that already introduced the internet technology usage in South Asia. So we know the status of internet, especially IPv6 in South Asia. Now we move to IPv6 security. Why IPv6 security matters now? Due to the rapid global adoption, IPv6 is quickly becoming the new worldwide standard for network communication. And then fueled by modern technology, look like IoT, 5G, and campus network, that all of the technology necessitated requires IPv6. But we have the impact of the IPv6 adoption, the resulting security challenges, expanding attack surface due to the dual stack environment. Yeah, the dual stack environment create more vulnerabilities for attackers. Okay, and then in the IPv6 itself, the security is not automatically. So we need do something to use the IP security. We call IPsec. Okay. Widespread adoption and security risks. We know from the research, from the education research, deployed across academic and scientific network infrastructures using dual stack. The dual stack itself double policy complexity because use IPv4 technology and also IPv6 technology. Running the IPv4 and IPv6 simultaneously means managing two sets of security policies. Okay. Then the transition phase itself increase misconfiguration risk. Okay. Errors are common when migrating system, old system to the new system. In this case, if IP version 4 and move to IP version 6, creating security vulnerabilities. Okay, so let me rethinking the security, the shift from IP version 4 to IP version 6. We don't block ICMPv6. Why? Unlike IPv4, blocking ICMPv6, essential function of error due to the IPv6 use ICMPv6 in the form of neighbor discovery protocol, the protocol using ICMPv6. So we don't block the ICMPv6. Not like in IPv4, you can block the IPv4, ICMPv4. Okay, then sequential scanning is obsolete. The fast address space make traditional scanning impossible. So attackers will use other methods. Okay. In IPv6, no default NAT protection. The absence of NAT network address translations used in IP version 4, but IPv6 not use NAT. So by default, the device that running IPv6, we don't need NAT, and the infrastructures that protect the NAT cannot use in IPv6. Okay. So in IP version 6, new technical considerations need to be considered. Yeah. Dual stack mean double work. Running both IP version 4 and IP version 6 means you must secure and monitor two separate protocols because we use two protocols. Then in IPv6, auto configuration can expose devices. IPv6 use stateless address auto configuration. This can expose hardware MAC addresses, so potentially revealing device vendor and type of attackers. Then one more, automatic tunnels can bypass firewalls. Some operating systems create IPv6 tunnel automatically. So this one potentially creating unmonitored path into your network. Okay, move from IPv4 to IPv6 means new security landscape. Okay, we can see here no default NAT, network address translation, yeah, provide direct end-to-end connectivity and IPv6. So removing the network boundary often created by NAT because IPv6 not use NAT again. Okay, then fast address space. While not a security control, the immense address pool makes broad network scanning difficult. Okay. Then to IPv6, local network communication, we use neighbor discovery protocol. This protocol replaces ARP, address resolution protocol. For IPv4, it uses ARP, yeah, using broadcast-based resolution. Then we move to IPv6, they use NDP. NDP more complex, yeah, and targeted protocol. So IPv6 uses a new, more complex protocol for local address resolution. We call NDP, neighbor address resolution, neighbor discovery protocol. Okay, then in IPv6 we use multicast. IPv6 multicast, many core. IPv6 function depend on one-to-many multicast communication. Okay, then another landscape is built-in encryption. IPsec support is mandatory in IPv6. Unlike IPv4, IPv6 use and mandatory to use IPsec protocol to support the operation of IPv6. Yeah, but mandatory is also optional, so need another action from the user. Okay, we already know why IPv6 has a new security vulnerability. Now you can see here the major security threat on IPv6. We have six major security threat in IPv6. The first one is reconnaissance and scanning. Attackers can map network layout and discover active hosts for targeted attacks. But the second one, neighbor discovery protocol abuse. Exploit can lead to traffic interception and man-in-the-middle attack. Okay. Then the third, rogue router advertisement. Malicious devices can misdirect network, yeah, to pose as legitimate routers. And then the fourth, IoT and embedded device exposure. The fast address space makes insecure smart devices directly reachable from the internet. And then dual stack security gaps. Dual stack means IPv4 and IPv6. If we run the two protocols simultaneously, can create unforeseen security policy blind spots. And then another threat is on extension header. We call extension header evasion. So attackers can use complex headers to bypass firewalls and security inspection. Okay, so next we talk one by one of the security threat. Okay, the first one is recognition. Okay, there is shift to intelligent strategic, yeah. The strategic evolution from brute force and the old strategy become intelligent strategy, because we know on the AI era, so attackers also can use the AI to discover our network, our internet connections. Okay, there are three primary discovery techniques. First one, DNS address harvesting, yeah, by collecting IPv6 addresses directly from the existing DNS records. Okay, second one, multicast discovery mechanism. They utilize built-in IPv6 multicast features to identify active hosts on the network. Okay. Then another one, predictable addressing patterns. Yeah. Because IPv6 address distributed with some addressing patterns. So exploiting non-random or sequential patterns within IPv6 address assignment. Okay. For the first one, yeah, reconnaissance, and then the second one, NDP, yeah. Let's see, discuss first about the NDP. What is NDP? NDP, Neighbor Discovery Protocol, yeah. This protocol replace ARP and IP version 4. Yeah. The NDP itself handles local discovery and addressing tasks that usually performed by ARP and IP version 4. Okay. So the core function of NDP is to make address resolution, to discover the link layer address of a neighbor or on the same network, link local network. And then router discovery to enable hosts to locate routers on the local network to forward packet. And then another function is DAD, duplicate address detection, to verify that an IPv6 address is unique before it is assigned to an interface. So the neighbor discovery protocol covers more functions, yeah, into one protocol, yeah, compared to the IP version 4 that use its function, its protocol. Okay, but the NDP has security threat also. This is the anatomy of an NDP attack. Okay, see, attacker can transmit a fog message. The NDP itself use 5 messages: router advertisement, router solicitation, neighbor advertisement, neighbor solicitation, and redirect message. So attacker here can send deceptive NDP message, one or multiple of the 5 messages used by NDP. Attacker can send false messages to a victim on the network. Okay. Then a neighbor cache, the victim neighbor cache is updated. Yeah, because he received false message from the attacker, so the victim neighbor cache is updated with false information. Yeah. Okay, then the impact of false information used in the NDP, attacker can enable man-in-the-middle attacks, allowing the attacker to intercept sensitive data. And then another attack is DOS, denial of service. That attack can be used to disrupt network services and block legitimate traffic. Okay. Then the third threat is RA, ROC RA. You can see here, RA is one of NDP messages that use some information sent by the router to the host. The routers send RA message using not broadcast, ya, multicast, ya, multicast transmission, ya. Okay. Three of message included the RA message as default gateway information and the network prefix information and select setting, stateless address auto configuration setting. All the three information sent by the router to a new host connected to the network. So after got the three message, the host will respond by use the three message to build new IPv6 address. If the automatic host trust, by design host trust the RA message by default. So if the RA message contain wrong information, so the host will create wrong IPv6 address. Okay, this is more details of the router attack that used by attackers on RA message. Okay, first one, attacker multicast fake messages, not broadcast, ya. Multicast messages. Attacker on the local network send raw RA message. Okay. Then victim select malicious router because the RA message contain router information. If router information is wrong, so the victim select wrong router, select malicious router. What is the consequences? The consequences is man-in-the-middle attack. So the attacker can now intercept, view, and alter all the victim network traffic. Okay. Then the attacker can send users to phishing sites or other malicious destination. And then another one, attacker can block access to the legitimate network, causing DOS, denial of service. Okay, then the fourth on threat on IoT and IPv6. Okay, IoT expand under IPv6. Millions of new devices connect to network. Yeah, however, different characteristics create significant security challenges that organization must address. Okay, the first one, the sheer number of devices create a fast attack surface for malicious actors. Okay, then low CPU, because IoT is low energy, low CPU and memory prevent the use of robust and complex security protocols. Okay. Then with authentication, many IoT devices are deployed with default or easily cacheable credentials. Then poor path management. Inadequate update processes leave known vulnerabilities open to exploitation indefinitely. Okay. Then threat on the dual stack, the configuration possibility mismatch. So IPv6 by default, many modern operating systems automatically active the IPv6 protocol, include your devices. If you run your device, actually your device automatically run IPv6 protocol. Okay, because the vendor already make our device dual stack. So we need to know the invisible IPv6 vulnerability, yeah, including unfiltered IPv6 traffic. Malicious data can bypass all existing security controls, and attackers can exploit this gap to infiltrate the network without detection. Okay, then the last is a threat on extension header. Okay. IPv6 introduce extension header as optional field, yeah, that place after the IPv6 header. So extension header is optional thing that we can use or not use. But if we use extension header, security threat can be introduced to the network. Okay. Firewall and intrusion detection prevention system, IDS or IPS, struggle to analyze these attacks because the packet including extension header cannot detect it by the host. The host will see the packet with extension header, and extension header is need to use. Yeah. So in this case, attackers can use multiple headers together to obscure malicious traffic from the inspections. So the host cannot differentiate where is the extension header, trusted extension header, and distrusted extension header. Okay, so from the IPv6 threats, we need to use some best practices on IPv6 security. Yeah, the first one, we can use RA card. Yeah, RA card to prevent router advertisement attack. Okay, then we also can use to deploy DHCP-v6 shield, yeah, to block unauthorized DHCP-v6 servers on the network. Then we can also filter unnecessary IPv6 types to reduce the potential attack surface of your network. And another one, we can consider secure neighbor discovery protocol SEN, yeah, SEN, to provide cryptographic security for neighbor discovery messages. Okay. Then we can also conduct regular audits and penetration testing to identify and validate your security posture. And then another one, we can do monitoring and visibility to ensure our IDS and IPS fully support IPv6. Then we can also enable IPv6 logging and net flow to capture detailed traffic data for analysis and forensics. And then last one, we can integrate IPv6 event into your SIEM to allow for control monitoring and incident correlation. Okay, last one, I propose 4 key strategies for APAN, to share security incident, to make dissemination information about IPv6 security event across all APAN network, and then create collaborative testbed to establish shared environment for testing and validating new IPv6 solutions. Then document best practices to develop and distribute official guides to for effective IPv6 implementation and security. And then last one, invest in training and capacity building to enhance the skills and knowledge of network operator through dedicated program. That is all. Thank you for my presentation, and thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh.
Thank you so much, Professor, for highlighting the security challenge in the IPv6 networks. Thank you so much. So now we will take a short break for 45 minutes. Please be back by 11 a.m. Bangladesh time. We will resume the second session.
Assalamualaikum, Prof. Motaharul Islam. Nice to meet you.
Walaikum salam wa rahmatullah. I'm very happy to listen to you. Very informative presentation.
From where?
I am from Bangladesh.
Oh, Bangladesh.
Yeah,
Okay,
I'm a professor
welcome.
of CSE department in United International University. It's in
Hmm.
Dhaka.
Okay, I got your email. I will
Yeah,
email you
just
to
I want to
make potential collaboration.
involve
Yeah.
myself to this community because from 1999 actually I was involved in the IPv6 R&D. I applied this concept in my PhD also. That is actually based on the IPWS. I proposed the IPWSN. I mean IPv6 based wireless sensor network, and I have a couple of publications for that also. I had a plan, but due to the busy schedule, I couldn't. But still, I am doing some R&D in IPv6.
Okay.
But unfortunately, actually, the deployment, you see, the rate is very low. And I am guiding a master's student, in a project work for the, enterprise level implementation of IPv6 in Bangladesh. But I got one review that one expert has commented that, you see, this, financial issue is the main cause for the deployment of IPv6. Do you agree with this, Professor?
Yeah, same in several countries also like that. But appreciation to Malaysia. Malaysia is the leading countries in IPv6. Last time I was as a trainer of IPv6 in Malaysia also. Good morning, Mr. Ram.
Very good morning, sir. Very good morning.
I got your message.
Yeah, thank you. I just eagerly listen your presentation. It's really nice.
Mm. Mr. Ram from Nepal, right?
Yeah, I'm from Nepal, sir.
And with university.
No, actually, I work for part-time university as well, right? And I'm working in the ISP, one of the leading
Oh, ISP.
internet service providers.
Okay.
And the most of the like content which you present is more related to the app, is like a technical, right? And
Yes.
is
Yes.
really help to the operators, like big operators and the ISP, NSP community to like adopt IPv6. The people are like so scared to deploy IPv6, especially for the enterprise network, right? And then these things, this presentation or this type of like a knowledge sharing and some training help them to boost IPv6.
Okay. Last time, me and Dr. Nava, actually our classmate there, Dr. Nava. Hello, Dr.
Oh, yeah.
Nava. Good morning. We research together in NAFSIC, National Advanced IPv6 Center in Malaysia, USM.
Great.
Under
Great.
Professor Surya supervision.
Oh, great. Okay, are you also coming to APAC Business Council meeting in Nepal?
No, I don't have the information as Dr. Nafa invite us to share IPv6 security here.
Oh, I think APAC Business Council will share the detail for you as well. And then my humble request as well, if you have a time, if you can manage, you're welcome to Nepal.
Okay, thank you for your invitation. Maybe you can share me the information or invitation of your event, yeah.
Sure. I think the APAC Business Council will share the invitation for you as well. No problem.
Very interesting discussion. This is Hafiz here. I'm the co-chair with Dr. Nava. Dr. Nava and Professor Ramadass are my professors. They are my teachers. IPv6.
Oh, and FMU, right?
Yeah, also from NAV6.
Oh, so from NAV6.
No, I'm not NAV6. Professor Ramadass and Dr. Nava was NAV6 that time.
Yeah.
Do you I've seen your, as you said, the presentation are quite technical. Do you face problems to find the appropriate systems to do this work? Like, for example, array guard and all of that, because not all vendors, they can provide everything from A to Z. Especially for those who are managing ISPs, Dr. Ram. Do you face any challenges to find the appropriate vendors that can really help you with security related in IPv6? Because everybody worry about the cybersecurity specifically.
Absolutely. Because like when we deploy IPv6 at the time, we also work with the vendors regularly, right? And we face a lot of challenges with the bomb traffic and the CP device completely does not support V6, and the BNG also have it's like completely haywire, right? And it took lot of time to discuss with the OEM, and OEM also deploy some patches and fix, right? It's almost like more than 6 months, right? We got a very massive complaint from the customer in as well, right? We just disable V6, enable V6, R&D. Yes, doing R&D lab seems okay. When we do in the production network, their behavior will be completely changed. some of the PM might be completely changed, right? And it directly hit to the routing engine of the device, right? And then we need to apply so many filters. I think now I think most of the OEM vendors, especially Nokia, Juniper, Cisco, is pretty much stable, pretty much stable.
Okay. From academician point of view, the research is already done and not never ending research. So the research in IPv6 is still go on. But the collaboration between academician and practitioner, I think should be conducted because academicians is lack to practical data. So you
Yes.
and ISP mean practitioner that every day look at the real condition, real data ya. So our collaboration mean we need real data in the field, so the data can be used by me to find correct solution.
Yeah, you are absolutely right. You're absolutely right. Like that's why like the academic and the industry collaboration is required, right?
Yes.
Yeah, that's great. That's great. And then like I also like highlighted like APAC6 Council. I meet Dr. Suresh, Dr. Nawa, and found really helpful this for the industry as well, right? The professor, the researchers research on some subject matter expert, right? And we also face a lot of challenges in our production environment, right? And when we work in together with collaborations with academic and the industry, right? And it will be like it's like a more fusion, and it works like uh, in a appropriate proper way in the real time hands-on as well. That will be really great for the um, academician and the industry. We have a lack of time to resource on that part, and the researchers have a lot of experience on the researching this type of things, so that it will be win-win for both.
Okay, yes. I will propose to Dr. Nafa to make another discussion on this collaboration. Yeah. So
yeah, absolutely. I think Dr. Nawa will also come to Nepal for the APAC6 Council meeting. That will be in the April 9 and 10, right? Have you visit Nepal?
Not yet.
Yeah, please. My humble request, please visit once. It's a really nice country, right? And you will be really enjoy here.
Yeah. From Indonesia to enter Nepal,
Yeah,
is it need visa?
I think don't worry for the visa. We can manage. We can talk with the government and apply. I think it's for the Asian countries. The visa is honorable. That
Okay.
is not that much of hassle for the visa.
Okay. Thank you.
Thank you. No problem, sir. Okay, it was really nice to discuss here and meet with you.
Okay.
Thank you
I
very
will
much.
message my email. Yeah.
Sure. Please, sir. Okay, thank you.
So, what is the next session with Zara?
Yes. Next session, Dr. Navar and Dr. Sami Solai, they will talk. Two speaker on. Dr. Navar is currently doing the IPv6 training, so that's why I'm not able to hear.
This the APAN61 would be in April. I'll try my best to attend the RAM. So maybe I will see you there.
Sure. You're welcome, sir. You're welcome.
Okay. Okay, thank you. Sorry, guys, I could not be there physically this time due to some situations. I hope you had a good meeting there. I think quite a few people only has been this session. Let's continue. How was your meeting in the morning session? Is it good?
Yeah,
Everything okay?
yeah, thank you. It was good, but there's quite a number of comments. It was very interesting that links the academia and industry.
Okay, very good. Thank you, Dr. Hafiz, for sharing the morning session. I think Ram's still there, I think. Krishna, sorry, I could not join your session because I was engaging with.
It's okay, sir. Right.
Yeah. How are you? Krishna?
It's good, sir. Good.
Okay, right. Okay, let's continue this afternoon session. And unfortunately, my one of the speakers from India couldn't join last minute, so we'll just do a change of it. Then I will let after me, I will get Dr. Sami to speak about it. So, okay, my today's topic is AI-driven security. Security trends and challenges. Okay, so today, as the world of now changing, quite a number of challenges is there. Okay, security trends are changing. So in the IPv6 enabled 5G network, there are more challenges. So I think many of you to of communication that provides identification and location.
Dr. Nova, you are muted.
Can you hear me?
Yeah, now it's better.
Sorry. Okay. Let's solve that info address. In terms of, so in terms of future, designed to handle 5G infrastructure and billion of connected devices, including IoT, smartphones, and industrial sensors.
We are not
So
seeing
as you know now,
your slides is not there.
it's not there.
Yes, sir.
Can you see? Can you see the slide now?
It's still sharing, not yet. I think in that
Can you see
room,
the?
internet is a little bit low.
Oh, okay. I think the internet is. Can see now the slide.
Now can see, sir.
Okay. So today, as we see now, today's the latest trends are talking about 5G infrastructure with billion devices, including IoT, smartphone, industrial sensors are connected. So 5G and IPv6 cannot be separated today. So IPv6 provides you the higher number of IP address so that it can enable IoT devices to be connected. And today with the Internet of Things or Internet of Everything, all new devices need to be connected. So that provides with a high speed with 5G. So that is the current, and we are talking about 6G and 7G, which is coming. So all the current and future networks, as far as now, will be connected with IPv6. So that's why IPv6 and 5G cannot be separated. So we have to deal with this scenario. So what is 5G? So that is, earlier we were talking about IPv6, the larger address space, give you more connectivity. Current standard was upgraded from 1G, 2G, 3G, and 4G. So it is a wireless standard that allows high throughput bandwidth. And in terms of high performance, it provides ultra fast speed, ultra low latency, massive network capacity with high reliability. So with this 5G, now, as you know, a lot of people now require real-time application. So real-time application like autonomous driving, remote robotic surgery, all these things required high bandwidth. So since it's high bandwidth requirement, we have to work with a higher, most efficient way. Basically, so all this thing which is supported 5G in the 5G network, IPv6 provide the IP connectivity for this. So enable this networks to be running this high-speed network. Okay. So in terms of 5G, as you all know, there's 3 areas within the 5G. One called EMBB, Enhanced Mobile Broadband. The other one is called Ultra Low Latency Communication, and Massive MMTC, Massive Machine Transition Communication. So it supports 3 areas. All these are high-speed connectivities. So with 5G and IPv6 together, that can support a lot of devices. This is the current, and will be a future where that's connectivity of this will required by many future devices as well. So why security matters? Now, since one side is 5G, the other side is IPv6, this security is most matters. As I always tell you, usually whenever it comes to rolling out any services now, people are looking at, first they look at connectivity, which is high speed, and of course they want cheaper options. And the third thing is reliability, and reliability comes with security. So today, currently the attack surface, since more devices are connected, there's more entry point for potential attacks. Like Internet of Things, there's, I mean, few billion devices connected. How do we manage entry point of these devices is secure? So it's a big challenge, especially in the area of IoT, because of weak default security, making them easier to target. See, IoT devices are less less hard disk space, less memory. So and also low power. Sometimes it's difficult to run antivirus solutions or any security solution, malware solution. Okay, so a bit which will quite security effect. So aspect in this. So it's important that for us to manage this. Okay. So a lot of industries that connected to 5G work like in the area of healthcare, transport, utility now rely on this network, and failure is not an option. Let's say if you're running an autonomous car, if somebody attack the car and the car is failed, can lead to accident, then there's a big headache. And you do robotic surgery, something happens while the network you're using it and not secure, it's big headache. So all these things required security. Now, role of AI in security. Nowadays, AI is seen everywhere in terms of threat detection. So we are using AI to detect any threats going on. So basically, with the AI capability, we can analyze vast traffic to detect anomalies and DDoS attack and intrusion in real time. Sometimes this AI option that available allow us to detect problems with a quicker and easier. Then again, we look at the predictive security. We can actually forecast potential attack by analyzing historical data and pattern and preemptive defense strategies. So we can actually see what is the problem coming, and we can actually be prepared to face the problem. So that's what AI again problem. So automatic
Yeah, Dr. Nova, I think your voice is breaking. Maybe some internet issue. Low internet might be.
Please wait a minute. I'm contacting him again.
Okay.
Can you hear me?
Yes, can hear, sir. But
Okay,
your voice was lagging a lot before.
this internet connectivity is.
I think that room has a problem.
This whole
You are muted, sir.
okay. Can you hear me now? Sorry,
Yes,
I've
can
changed my
hear.
connectivity. Sorry about that. Whatever. Okay, sorry. So sorry for just now. The connectivity was not really stable. Okay, now we talk about in terms of threat detection. Basically, the AI now threat detection. We can actually AI analyze vast traffic volume to detect anomalies like DDoS attack, intrusion in real time. Predictive securities forecast potential attack by analyze historical data pattern for preemptive defense strategy, as I've just talked about it. And again, the AI can automatically isolate affected network segment to contain threats without human intervention. Okay, so these are all the advantages in AI. Then we have adaptive defense, basically dynamically update security policy and protocol in real time as network evolves. Then the latest security trends, federated learning. Now train the AI model across decentralized devices without sharing raw data or ensuring privacy. So AI-driven zero trust, implement continuous verification of every access request and regardless of origin. Then behavioral biometric, detect unauthorized access by analyzing unique user behavior, patterns, and interaction. So these are the latest trend. Then again, coming back to using cloud and edge AI, we can deploy AI closer to the data source and faster detection in case of any security and immediate response. So currently, what are the key challenges? In terms of adversarial attack, AI can be fooled by deceptive input, leading to false negative or misdetection. So we can actually basically able to cheat the AI system or with several command basically poisoning the AI, so forth. Privacy concern, balancing protection of sensitive user data while enabling AI learning. As you know, AI is there, but some of the issues with the security issues, the AI easily can be manipulated the data. So we have to be aware of that. Then resource constraint, basically limited processing power and edge devices restrict the deployment of advanced AI models. Then in terms of scalability, AI system must handle massive traffic load without degrading the network speed. So in terms of skill gap, a significant global shortage of experts is in the intersection of security and networking and AI. So these are the key challenges comes to AI. The future, 6G and beyond. So now, earlier we spoke about 5G and IPv6. We spoke about the attacking area. Now, even now itself, we have a lot of issues in 5G, security issues that try to address. Now the world is moving to 6G. With the next gen 6G, we deliver ultra high speed, persuasive intelligence, and enable holographic communication. This is what led us in 6G. Now, in terms of security, we'll be doing AI-driven security, moving fully autonomous network management and self-healing system. Then we use a collaborative AI, real-time threat detection and response coordination across a massive global network. Okay, so this is the future going to be. So what is the AI area? Explainable AI. So making this explainable AI is in progress. So making AI security decision interpretable and transparent to human operator to build trust and accountability. Okay, so this is something new area of AI is happening, explainable AI. Then we got AI privacy preservation. Basically developing a techniques like different privacy to protect different individual data points while maintaining the model accuracy. Again, quantum safety security. Now the current encryption system is no longer relevant, like AES and so forth. Now we are looking at quantum. So preparing cryptographic defense today to withstand the future threat posed by the quantum computing capability. So we need to focus on this area in terms of protect the security of the future networks. Okay, so that's it for me for this morning. Is there any questions you want to ask? Is Sami is joined? Sami is joined.
Yes, join, sir. Okay, thank you so much, sir.
Any questions? Anyone from the?
Yes, hello. Can you hear me?
No. Yeah.
Okay. My name is Panaton from Kasetsart University, Thailand. So like my university is deployed IPv6, and then now we are using dual stack for both IPv6 and IPv4. But then I want to ask you about what should be next step. You know that like when now we are using mainly IPv4, but we want to change to IPv6 such that we are deploy IPv6 with dual stack. But what is the next step in your opinion? That's my question.
Okay. Thank you. Good question. Now we want to move from IPv4 to IPv6. That nowadays, not even IPv4 anymore with discussion. We are not talking about IPv6 only network. So in terms of there's a certain challenges before you want to move. Normally, if you ask me if you want to move to IPv6, first of all, you need to assess what are the devices that you have that support IPv6 and IPv4. Okay, the assessment need to be done of the existing equipment, both the hardware, software, applications, so that you can evaluate what you're supposed to do. Actually, nowadays, honestly speaking, all these devices, software, hardware, all support IPv6. So first, you need to do, eventually do that, but you need to make sure that the assessment is done. okay, on your current network. Then if there's any stopgap measures, like actually some doesn't support, some support, then you need high time to actually purchase a new product, because you cannot upgrade. Sometimes you cannot upgrade existing product. Nowadays, upgrading is not encouraged in that sense, because especially IPv6 concerned. So better get a new product to support your IPv6 rollout. So that is one. Generally, in terms of hardware, you need to do assessment. Then again, you need to do a planning, IP addressing planning, so that you can effectively distribute the IP address that you are getting. That's more important. Then the third item is the security devices. Make sure your firewall on all the security devices support IPv6. So generally nowadays everyone supports it. If not support, make sure that you use that the word product that try to buy the product that support IPv6 and enable them in your network. So these are the basic requirements that you needed to make sure that you roll out IPv6 successfully. So these are the things that you need to do. So I can just conclude that please assess your network, see what is the gap, what you have, what you need to do, then procure the relevant component, then basically you can roll out IPv6. So most of the time in a cloud environment, if you are doing things in a cloud, nowadays we have, this morning also I've shared some of the tools in the cloud. You can use it to enhance the performance. Okay, so this is something that again, like players like AWS, now they, instead of IPv4, they might charge you extra. IPv6 is come free. So these are things that are happening. I think by 2030, we only want to see majority of networks in Malaysia is only IPv6 only. So this is what the direction will be. Okay, so moving forward to IPv6, definitely there's a lot of advantages. So you need to do a proper planning for implementation and save costs in the long run. Thank you. Any other questions? You clear?
Yeah, thank you very much for your answer.
Thank you.
Thank you, Doctor. So our next speaker is Dr. Sami Saleh from Saudi Telecom. He will present on latest IPv6 only rollout updates in the MENA region. Dr. Sami, you may start your presentation.
So thank you for having me. I'm sorry I don't have a slide for this presentation, but I just will give some highlights on some update on IPv6 implementation in our region, the MENA, Middle East, North Africa.
You're not eating, why are you all not eating?
Dr.
The food is
Nawa,
ready.
you are, hello, Doctor. Thank you.
Okay, so in most of our region, the regulatory and government are leading the implementation of IP V6 rollout in their corresponding countries, and most of them they have KPIs to be reached for IPv6 traffic. As I'm based in Saudi Arabia. Saudi Arabia now leading the region with more than maybe 7% of the internet traffic is using IPv6, followed by United Arab Emirates. This is in the Asian part of the Arab countries. On the African part of the Arab countries, Egypt and Tunisia, they are leading the implementation. Unfortunately, there's a huge gap between those leading country in IPv6 and the rest of the country in MENA region. Some of them are behind that. They're less than maybe 10% of their traffic are IPv6. Considering that the political situation in our region and the instability. Some of the country are used to have about 50% of IPv6 traffic in several years, but now this percentage are decreasing due to the situation and due to the foreigner internet usage from satellite provider covering the region. Beside the IPv6 rollout, there is a direction to move to 5G, standalone 5G network, and other techniques that need IPv6 as a basic resources to go to those technology, including SRv6 5.5, 5G, and other technology that IPv6 will be necessitated for that. In Saudi Arabia, maybe 7% of the country is covered with 5G network, but it's not fully standalone network. But they have a promising plan to implement the standalone 5G by the end of this year, 2026. Other countries are following very fast, but there's the gap is still there in 5G and SRv6 technology. All those statistics can be shown in APNIC labs for IPv6 and for other statistics, and there other official site you can follow the implementation of those technology in our region and comparing to the world. This is all from my side. I'm sorry I didn't prepare that slide to show the results, but if any question regarding the IPv6 in MENA region, I'm ready to answer that question. Thank you.
All right, sir. Thank you. So is there any question about that? Any discussion, because it's the end of the session now. All right, I guess there's no one. So that brings us to the end of the today program. On behalf of the organization committee, I sincerely thank our distinguished speakers and all participants for joining us today. We look forward to seeing you again at future APAN IPv6 and 5G working group sessions. So thank you so much, everyone. Have a nice day.